So the other important structure for most programming, and it's no different in MATLAB, is for loops. So for loops are useful if you want to do something repeatedly, and we often want to do something repeatedly. We often want to do something for an entire time course, or for each data point, or for each replicate. And the beauty of programming is that we can do something for 1,000 data points as easy as we can do it for one data point. So that's where for loops come in. The syntax for a for loop in MATLAB is the keyword for. And I want you to type this again. Notice I'm in a new editor window here. You can get that by hitting New Script at the top left, by typing Edit on the command line, or even by pressing this little plus button a bit like you would in your browser to open a new blank tab. Then I want you to type for, which is the keyword to begin a for loop, and then you have to define a variable to iterate over. Stay there, buddy. Okay, so what this code is going to do is set a variable a equal to 10 the first time, 11 the second time, 12 the third time, etc., all the way until 20. So remember when we saw this colon notation before, we defined an array to be 1 colon 5, and we found that that gave us 1, 2, 3, 4, 5. So we saw that yesterday, and we're making use of that here. 10 colon 20 is going to give us 10, 11, 12, all the way up to 20. And we're going to set a equal to that value one by one. So a will be 10 the first time through, a will be 11 the second time through, all the way up to 20. And then we indent into our for loop, and we do something for every value of a. So when a is 10, we're going to fprintf that the value of a is 10. When a is 11, we're going to fprintf that the value of a is 11. And we're going to do that for every value of a. Now, just to recap on these fprintf statements, this means that we want to print to the screen the value of a is some number, and then remember that the \n is a new line character, so we want to print each time on a new line. The value of a is some number, then we have a new line. And what number do we want to substitute in there? Remember that %d means we want to substitute a whole number in, an integer. The value of a is some whole number, and we're going to substitute in that value a into that space where it says %d there. I put a semicolon at the end of this line. I have an end statement. You always finish your for loops just like your if statements with an end. And then when you hit run on this code or type the name of the file, for example, I typed for loop example here into my command line, you should see the value of a is 10, the value of a is 11, printed all the way from 10 to 20, each time on a new line. Okay.
I'm sorry, what's the \n again? Is what?
What's the what, sorry?
The backslash goes to the next line. Oh.
So that's a new line character that just makes sure, otherwise, without that, you would see value of a equals 10, value of a equals 11, all on one big long line, wrapping around the screen. So the \n is a carriage return, new line character. Okay, so we're going to combine everything we've learnt so far to write a little script that takes a gene name and some expression values and outputs only those genes that are over some threshold. I want to introduce a little concept here called pseudocode, which is a computer science thing that you might have come across in other languages, which just means to think about, in plain English, how to accomplish the task that you're about to accomplish. It's really good to, before you open your document and start typing code, to think about the algorithm that you're going to use to solve the code. Because otherwise you'll start typing, you'll find you've done something a bit wrong, you'll have to go back and change it, and you're sort of typing as you're going along rather than solving the problem and then committing it to code. So to solve this particular problem, I've written some sort of loose pseudocode about what I might do. The way I think about this is, how would I, if I could talk to a computer and give it instructions, what instructions would I give it in English? Well, I would tell it for each gene in a list, if its expression value is over the threshold, print the gene name and the expression value. So this is just the broad algorithmic approach that I want to use. Now that I know that this approach will accomplish the task that I want, I can convert those lines into real code using the things we've learned so far. So here's what that might look like. I've left the pseudocode at the top. The first thing I want to do is define my inputs. These are the variables that I'm going to use. Now you'll notice a new data structure being introduced here. Everything we've come across so far has been in square brackets, but I mentioned cell arrays yesterday that allow you to store lots of different data types and different lengths of data, and we're using one of those here. So we're storing these strings in a cell array, and you can tell it's a cell array because we have these curly braces rather than those square brackets. Apart from that, you can think of them very similar right now. So expression 1 genes contains this list of gene names. They're some of my favorite genes from my work. And then expression 1 results. This is a regular array. We have the square brackets here, and we're storing some expression values. It's the same length as our list of names. So this might be some expression values from an experiment you've done, and these would be the gene names corresponding to those values. Then I have one final variable, which is a threshold, which says I only want to output those genes that are over this threshold. Then let's think about my pseudocode. I want to do something for each gene in my list. So what we have here is for I equals 1 to the length of the expression 1 results. So previously, our last for loop that we saw said from 10 to 20. You could do from 1 to 20 or whatever, but we want this to be able to work for any length of gene list. And so we're going to make use of the length function that we came across previously. And we know that length will give us the size of the longest length of our array. For this one-dimensional array, it's going to return 1, 2, 3, 4, 5, 6, 7. So length exp1 results will be substituted with 7. So now we know that this will go for I equals 1 to 7. And what do we want to do for I equals 1 to 7? Well, if its expression value is over a threshold, we want to check that. So if exp1 results I is greater than the threshold, this notation here, exp1 results I, will check the ith element of our exp1 results. So the first time, I is going to be 1. It's going to check exp1 results number 1, which will be this 4. It's going to check whether that is over the threshold. So is 4 greater than 20? That's going to be false, so it's not going to do anything. For the second gene, it's going to check, so it's then going to set I equal to 2, check whether exp1 results 2, which is 56, is greater than the threshold. Is 56 greater than 20? That's true. So what do we want to do for our gene that's over the threshold? Well, I want to print the gene name and the expression value. So I'm going to fprintf gene, some string, expression, some number, new line character. So we've seen print statements like that before. And then we know that after the print statement, after a comma, we have to have the values we want to substitute in. So we want to substitute a string in and a number in. And here we're going to substitute in the first string, which is going to be the gene name, and then here we're going to substitute in the value, which is going to be the results. Now the eagle-eyed among you will spot that we've used slightly different brackets here. So to get the ith element of a cell array, we have to use curly braces. To get the ith element of a regular matrix or an array or a vector of numbers like this that we have defined with square brackets, we have to use these normal brackets here. So that's a key difference. We define cell arrays with curly braces. We also access the numbers in them using curly braces. So apart from that, this is all stuff we've seen before. So we're going to go through for I equals 1 to the length of exp1 results. We know that's going to be 7 in this example. So I will be 1 the first time, 2 the second time, 3 the third time. We will get the first gene result, then the second gene result, then the third gene result, checking each time whether it's greater than the threshold. Only if that's returning true will we print the gene expression and the result value to the screen. Yes?
So, was there a reason you used I at
Right, I said to be careful with I. If you launch MATLAB and type I, you'll find that it's already defined. That doesn't mean you can't overwrite it and use it. So I wouldn't avoid using I, because it's computer science standard to use I, J, and K for your indexes in your loops. I equals 1 to something. Then if you're nesting in again, you often use J equals 1 to something. If you don't like using I, you could use index or some other variable name you wanted to. The only thing I said to be careful about with I is that it's already going to be defined. But that doesn't mean you can't overwrite it. So if you open MATLAB and type I, I'll show you now. So if I open MATLAB, I haven't, in fact, I can close MATLAB. I can reopen MATLAB. Maybe. So here, I've just launched MATLAB. There's no variables defined in my workspace, but if I type I, I'm given the imaginary number with 0 real component and 1 imaginary component. That doesn't mean I can't redefine I. So if I say I equals 1, now I check I, it's 1. So it works just like any other variable. The only thing you need to be aware of is that when you start your session, it's already defined, and you need to make sure you're giving it a value. So we're fine to use it here in our code because we are defining it. So I've said here I equals, and we know that any statement with an equal sign will define a variable. And so whatever value I had before we used it, it's now given 1 the first time through, 2 the second time through, so it's perfectly fine to use it. OK, so the next structure that I need to introduce is very similar to a for loop, but it's defined slightly differently and has a slightly different job. It's called a while loop. Again, we define it with the keyword that is while in this case. It was for loops. It's while for while loops. And then what we want to do is do something repeatedly while a condition remains true. So the for loop automatically set a equal to 1 the first time, a equal to 2 the second time, etc., through our list. A while loop doesn't do that. What a while loop does is just keep repeating as long as some condition is true. So let's see an example here. We're going to set a equal to 10. Notice I've written myself a code comment here. I've used that percentage sign on a line on its own, and it's highlighted in green, and that's MATLAB telling me that it's just going to ignore this, and I've written a note to myself. So while a is less than 20, well, we know 10 is less than 20, so that's going to be true the first time, so it's at least going to run once. So while a is less than 20, I'm going to print that the value of a is some number. I'm going to have a new line character. I'm going to substitute a into that print statement. And so we know that's going to run the first time because 10 is definitely less than 20. Then I set a equal to a plus 1. So whatever value a has the first time, which is 10, a is now going to become 11. And then it's going to check again. It's reached the end of the while loop, so it goes back to the top and checks whether the condition is still true. So is 11 less than 20? Yes, it is. True. So it's going to print again and then add 1. Is 12 less than 20? It is. It's still true. It's going to do it again and again while a is still less than 20. Eventually, it will reach 19. It will print 19. It will say 19 equals 19 plus 1. It's going to add 1 to a, and so a will become 20. It will then check whether 20 is less than 20. 20 is not less than 20. That's going to be false. And then it will end the while loop. So you should see all the numbers 10 to 19 printed. You'll note that this is very similar to something we achieved with the for loop just now. However, we're using a different notation. There's no right or wrong way of doing this. Many times you can accomplish the same thing with a while loop or a for loop, and whichever you're most comfortable with is fine. They can have slightly different uses if you're waiting for a file to finish downloading, if you want to do something while you're connected to a server, or before you have reached the end of some data stream, it's better to use a while loop. But if you're just looping through a data structure, you can use either a while loop or a for loop, whichever conceptually you're happier with. I find I write a lot more for loops than while loops, but it's your personal preference, whichever you understand best.
How do you stop it if it never ends?
So if you make a mistake like this and write while, let's do it in here, a equals 1, while a less than 5, I want to printf, or I can just do disp a, I guess, for now, disp a, and then end, and I've forgotten to do the a equals a plus 1, so I'm not actually going to iterate through my code. If I run this infinite test, you'll see it printed forever and ever and ever, and if you hit Control and C, it will terminate your infinite loop. So don't be afraid of getting stuck in infinite loops. You can hit Control C and it will tell you that the operation was terminated by the user. And clearly what I did wrong here was that I didn't iterate my number. Now that I am doing, it should only run 4 times. Great, okay. Where's my, there it is. Okay. Everyone follow that example of a while loop? Awesome. Okay, so here's just a recap that you can do the same thing with for loops and while loops. The advantage of a for loop is that it automatically defines the variable for you within the scope of the for loop, and it automatically iterates it through. So this for loop here accomplishes the same thing as this while loop here, but for the while loop we have to define a variable, a equals 10, and we have to make sure that we iterate a equals a plus 1 every time we're within the loop. Whereas this for loop automatically says b is 10 the first time, 11 the second time, 12 the first time. So it's a little more concise for this particular example, but they both achieve the same thing. Okay. So the other thing to talk about when we're talking about while loops is break statements. So the while loops we've been seeing until now have all ended because the condition has become false. They've kept going while the condition is true. Eventually the condition has become false and the while loop is finished. So the other way of ending a while loop is with a break statement. What a break statement will do is it will terminate the loop that it's in and move on to the end of the code, to the end of the while loop at least. If there's more code after the while loop, it will continue at that point. So here's an example. It's very similar to the while loop we saw before. Start with a equals 10. While a is less than 20, we want to do something. What do we want to do? Well, we want to print that the value of a is some number, and then we want to add a equals a plus 1. So we want to iterate over a. So everything until that point looks like it's going to print all the numbers between 10 and 20. It's going to start with a is 10, it's going to print 10, it's going to add 1 to a, and then print 11, etc., all the way up to 20. However, it's not going to do that all the way to 20 because we have this break statement here. So I've put my break statement within an if statement. So if a is greater than 15, so that will become true at some point. A will be greater than 15. And when that's true, I'm going to run this break command, which will exit the loop that it's in and mean that we don't print all the way from 10 to 20. We actually only print up to 15. So it will set a equal to 10. It will print that a is 10. It will add 1 to a. It will check whether 10 is greater than 15. It isn't, so it won't run the break statement. It will then do 11, print that the value of a is 11, add 1, check whether 11 is greater than 15. It isn't. 12, 13, 14, 15. When it gets to 15, it's going to add 1 to a to make it 16. It's going to check whether 16 is greater than 15. That's going to be true, because 16 is greater than 15, and it will execute this break statement, which will jump straight to the end of the while loop, and you won't see any more values of a printed. So that while loop terminates without this condition ever becoming false. So the actual condition here has not been relevant in this example. What's actually happened is we've hit the break statement, and that's terminated this while loop. It's an important thing to be aware of. Usually you want to write your code such that break statements aren't necessary. Usually if you've thought through your code well and structure it well, you won't need many break statements. However, if you inherit code from someone else in the lab and it looks like it should be doing something for 20 values and it's only doing something for 15 values, or it looks like it should be doing more than it is, have a look out for break statements, because you could be hitting a break statement before the code that you're trying to get to execute is actually running. Great, okay. Yeah.
So some by the end of the line we have semicolon, some of them don't have it. So is there any kind of special rules of the implementation?
What you should be doing is putting a semicolon at the end of every line that is not defining a conditional loop. So like our while statement is opening up a block of code to be run, so we don't have a semicolon at the beginning of that. While I is less than 20 lines up with an end, and all the code inside it becomes indented underneath. The same for the if statement. It's only going to run the code that's indented underneath it if some condition is true, and it lines up with an end statement, so we don't need a semicolon at the end of the line. However, all the other lines that might be printing stuff or setting and updating variables or executing any functions will all need semicolons at the end of the line. So as a general rule, it's anything that's lining up with an end statement we don't need a semicolon at the end of.